this sample is not one copper atom. It is a lot of copper atoms. But to represent this in terms of its name, we would write copper. And we write it in English. That's not the way it looks in other languages. But if you were to look on the periodic table that I handed you, you don't see the word copper, you see a bunch of symbols. And so one of the things that you need to start learning are some of the most common element symbols. And Cu is the symbol for copper. If you can find the symbol, then you can look and see where it is on the chart. And so this is done in columns and rows. And so the column that it's in has a 1B over it. So whatever is written above the column, that's called its group number. So on the periodic table, the columns, they are called groups. So we have numbers and letters. It's either an A or a B. And the numbers range from 1 to 8. So copper is in 1B. And then it is in row 4. And the rows are called periods. So it is in period 4. So this is its row. This is its column. Basic information, but you still need to understand it. So if you're talking about what period something is in, then you're looking at these numbers. Down here at the very bottom, there's 2 additional rows. And those also have numbers written next to them at 6 and a 7. Those are the same numbers as this 6 and this 7, because guess where this 6 actually goes? In row 6. If you look at the numbers, that says 58. What number comes before 58 numerically? 57. There is element 57. 58 goes there. It jumps from 57 to 72. No, it doesn't. They just pulled them out and stuffed them down here. There is number 71 right there. Okay. So I have put the correct period number beside these bottom 2 rows also, because they actually go right there. There and there. Okay. If you look at copper and you look inside its box, you see a 29 over it. Every element has a whole number right above it, right above the symbol. That number 29 is called copper's atomic number. Nothing else has atomic number 29. The periodic table is in order by atomic number. Because if you look at the numbers and you just look at the number above each symbol, there's 1. All the way over, there's 2. There's 3. There's 4. 5, and then. So each one of the elements has an atomic number. That atomic number is equal to the number of protons. And those protons are in something called the nucleus. So if an element has 29 protons in the atom, that element has the identity of. The other two larger subatomic particles that we look at in chemistry are electrons and neutrons. The number of electrons and neutrons do not determine that it's copper. They determine the total mass of the copper or the total charge of the copper. So we're going to look at those two things kind of separately, but they're all part of an atom. So you want to do the mass or you want to do the charge first? Charge. Okay. So for an atom, all atoms can be neutral. So the word neutral that means that it has zero charge. And the way that we look at an atom and determine whether it has a charge or not is we look at the two particles that make up an atom that give it its charge. And one of those is protons. And so protons have a charge. Does anybody know what kind of charge protons have? Positive. So protons are positive, and we're not going to use the actual measured charge. We're going to use the relative. And so electrons and protons are opposite each other. And so we're just going to say that the protons are positive and the electrons, the opposite of a positive is a negative. So the protons, how many protons does copper have? 29. And so we're going to put up a positive. This is not a plus, it's a positive. We're going to put a positive in front of that. And every single one of those protons we're going to say is positive. So how many positives does it have? 29. So in parentheses right here, I'm going to put the 29 protons. So there's positive and there's 29 protons. Each one of those is positive. Okay. The opposite of positive is negative. And so each electron is negative. It's not a minus, it's a negative. Each individual little piece is negative. And if I wanted something with a zero charge, if I have 29 positives, how many negatives would I need to have? None. And if you add those together, you get 0. So we are going to use this little formula. And I hope it looks elementary to you, but that doesn't mean you should ignore it. Positive in front of the number of protons, and then a negative in front of the number of electrons. And then you're going to pretend you're in elementary school and you have them stacked together and you just go straight down. And if they're not the same number, you're not going to get a 0. If you have more negatives, the answer will be negative. And if you have more positives, the answer will be positive. Okay. Does that make sense? So one of our formulas that we're going to use, the charge is going to be the positive protons plus the negative electrons. Protons, electrons, so we get this charge. Is that neutral? This copper right here is neutral. Neutral metals look metallic. Has anybody ever seen copper that looks green or blue? That is not the zero charge. Zero charge metallic bonds, they look like metals. But if this gets messed up, now it can't lose protons because they're in the nucleus, and then that would be a nuclear reaction and it would turn into something else. But if the number of electrons gets messed up, then the appearance of the copper goes away and it turns into ions. So metallic is neutral, but if it's an ion, I'm going to write it this way: Cu positive 1. In the upper right-hand corner, I'm going to put a positive 1. If you see a symbol or a group of symbols with something in the upper right-hand corner, then you're looking at an ion. So this is an ion. And I want you to think positive don't think plus, because plus means addition, and that's not what we're doing. And then your mind goes into addition, subtraction, and then it all gets messed up. Okay. So if the charge is positive 1, then when we add the numbers together, our answer is not going to be 0, it's going to be positive. It is copper, so how many protons is it going to have? 29. Because all copper has 29. And it's still going to have a lot of electrons, but there's just not going to be 29 of them. So if I got 29 positives, how many negatives am I going to have if I still have a positive leftover charge? 28. So this thing has 1 less electron. This is our little formula that we'll do. If you know protons and electrons, you can add them together and get the charge. Or if you know the charge, you can figure out how many electrons or protons. Okay. There is another ion of copper that has a positive 2. That is its charge. How is this copper different from that one? It has a different charge because it has a different number of something else. Okay, what do all copper atoms have? 29 protons. When I add that with the electrons, I end up with a positive 2 answer. So how many electrons does the positive 2 copper ion have? 27. So it doesn't have negative 27 electrons. It has 27 electrons. Each of them is negative. It's just a little bit of a mind shift about what you call these things. But if something has a positive or negative charge, we refer to these particles as ions. If it is no charge, that's just called an element. Neutral. But if it has a positive or negative charge, it's called an ion. What would happen if an element has more negatives than it does positives? It'll be negative. So this is the charge. Now we're going to look at the mass. The mass of a copper atom, that's not the positive two. And this would be an individual atom, not this whole entire, not that whole sample, but if I just chipped off one tiny atom. Okay. The mass of a copper atom is called the mass number. So it's two words that go together. Just the word mass by itself does not mean mass number, and the word mass with some other word does not mean mass number. Only mass number means mass number. Okay, to find the mass number, we take our protons and we add them to our neutrons. And that gives us our mass number. Up here in our formula up there, we had two things that we added together to get an answer. In order to add things together to get an answer, you have to know what the two individual things are. Or in this case, we knew what the answer was supposed to be, and we knew how many protons, so then we were able to figure out our electrons. Any kind of math problem, when there's three variables, you got to know two of them. So this is not something that you can just magically know. We do magically know 29. So there are two main atoms of copper that we would find, and those are called isotopes. So the atoms of copper are called isotopes. And the two main ones that occur naturally on Earth are copper. I'm going to put a little 63 in the upper left-hand corner. And the other one is copper with a little 65 in the upper left-hand corner. That number that I just put into those upper left-hand corners, that is the mass number. Upper right-hand corner would be an ion charge. If you ever see a number in the upper left-hand corner, it's the mass number. So some of these copper atoms in this sample have a mass of 65, and some of them have a mass of 63. So if the mass is 65, then what would my formula be? Well, if my mass is 65, will be our neutrons, however many that is, plus how many protons? 29. So 29 protons plus some number of neutrons should give us a mass of 65. So how many neutrons would be in the atoms that have a mass number of 65? How many? 36. So these atoms right here have 29 protons and 36 neutrons. What about the ones that have a mass of 63? That would be, our total is 63. And we have a certain number of neutrons. And I'm just going to put a little n with a 0 there. And 29 protons. So 29 plus 34. So what I've done with these, showing you the ions and separately the isotopes, is I've tried to show you how the atomic number, when you compare it to the electrons, you end up figuring out the charge of something, of an atom. And if you compare the protons and the neutrons, you end up finding the mass number of the atom.